Hi, everyone. We're going to do the Unit 2, Lesson 1 practice problems. So if you're looking for this in your book, it's on page 57, or if it's online, depending on how it was assigned, make sure you find it on there. But I'm working in the book today. Let's see here. Can you see this okay? This is very weird for me because I'm recording myself from my right side, which I don't think I've ever done in like the hundreds of videos I've made. I always record to my left, so this is weird. All right, so it says, fill in the missing number at every hash mark to complete the diagram. We call these double number lines. These number lines are the same length, but their increments are different, right? This one is going all the way from 0 to 10 in the same length that this one's going 0 to 5. And so between these double number lines, there's going to be some equivalent ratios, sort of like the stuff we're working on in class. Like if you look at this 5 and this 10, well, 5 times 2 is 10, right? And if you look at this 1 and this 2, 1 times 2 is 10. And so you want that relationship to stay the same the whole way out, where whatever is here times 2 is going to equal this. Well, the top one's pretty easy to fill out. It's just the counting numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, the bottom one is like each increment is worth half as much. That's why you have to multiply by 2 to get to the line on top. And so if we mark each increment off here as 1/2, I'm going to use fractions. Half, 1, 1.5, 2, 2.5. I guess I'm using mixed numbers, not fractions. I should have said 3, 3.5, 4, and 4.5. If you choose any of these numbers down here and match it with the number above it, like this 2.5, if you multiply that by 2, you get 5. So we maintained this equivalent ratio relationship among the two lines the whole way, which is what we wanted to do. So next, here we have a recipe for orangey pineapple juice, along with 4 other versions of that same recipe. Circle all of the recipes that will taste the same as the original. So there's only 2 ingredients in the recipe, right? Orange juice and pineapple juice. If you want your recipe to taste the same as its original, then you just have to use the same ratio of orange juice to pineapple juice. There's less orange juice than there is pineapple juice in here. So like if you were to mix it up and maybe use more orange juice than pineapple juice, obviously that recipe wouldn't taste the same, right? Maybe I shouldn't record this close to the windows. I hope that's not too loud. But yeah, so we're just looking to keep the ratios equivalent so that our recipe tastes the same. And what I would do, since we're kind of learning about this in class, is I would call one of these values y and call one of these values x. I'll just do it like that. It didn't really matter which one I picked here. And I want to find a constant of proportionality, which you find by doing y divided by x. And so in this case, that's going to be 15 divided by 10. That can simplify down to the fraction, well, let's see here. If I divide the top and the bottom by 5, I get 3/2. So that's 3/2. You could also think of that as 1.5 or 1.5, whatever works for you. So basically, however much orange juice we put in this recipe, we need to be able to multiply that by 1.5 or 1.5 and get the amount of pineapple juice. That's our ratio here. And so let's just check each of these. If you take the amount of orange juice and multiply it by 1.5 and you get the cups of pineapple juice, then you know you have a recipe that's going to taste the same as the original. And this one works. 4 times 1.5 is indeed 6. So that one's good. We should circle it. Now this next one, look, I'm not even going to check it. They're trying to trick us. Because if you took the pineapple juice and multiplied it by 1.5, that would equal 3 for the orange juice. So the 1.5 is there, but see how it's reversed? They've got more orange juice than they have pineapple juice in this recipe. So this is going to be some super orangey pineapple juice, which we don't want that. So recipe 3, 9 cups of orange juice and 12 cups of pineapple juice. Well, if I do 9 times 1.5 or 1.5, I don't think that's going to equal 12. We can always check with a calculator. Let's see. 9 times 1.5 equals 13.5. So this one doesn't have enough pineapple juice. So it's probably still going to taste a little too orangey or maybe not pineapple-y enough. So we're not going to select that. And then the last one, we got 6 cups of orange juice and 9 cups of pineapple juice. And so if we do 6 times 1.5, that does indeed equal 9. And so this one also has that good orange to pineapple ratio that we wanted so bad. So here it says, choose one recipe that you circled. Okay, I guess the first one. And explain how you know it tastes the same as the original. I guess I shouldn't have written right here because I need that space to answer this question. Okay, let's see here. I know recipe 1. I don't know why I wrote the word 1 out instead of using the number 1. Will taste the same as the original. I like to shorten original as orig, because the ratio between the ingredients. Now I drew a circle on this area too. I should have planned how I was gonna circle and show my work so I wouldn't have such messy work here. Because the ratio between the ingredients is the same. I should write the same as the original, but I'm kind of out of writing space. Choose one recipe that, so I'm on number 3 now. Choose one recipe that does not taste the same. How does it taste compared to the original? Okay, I'll just pick the first one that I crossed out. It's recipe 2. Recipe 2 would taste too orangey. It's not really a word, but whatever. Because it has more orange juice than it does pineapple juice. And that doesn't even follow like the basic standard of the original recipe, right? Number 4, to make a mixture that tastes the same as the original recipe, how much pineapple juice should you mix with 1 cup of orange juice? So this is what we would call the unit rate. When you're doing any question that involves ratios or rates like this, I know when people say rate, you tend to think of like prices and speeds, but right here, this question is really about the rate of pineapple juice versus orange juice. Rate, ratio, they're borderline the same word. And so unit, the unit in math is 1, right? Like when you're counting by units, but those units are 1. And so sometimes in math, the word unit sort of means 1. And so a unit rate is anytime you're talking about how much of this you need or how much of this you get for every 1 of this. And that's what they're asking us. How much pineapple juice for 1 cup of orange juice? So this is an important vocab word here, this unit rate. Well, it turns out that the unit rate and the constant of proportionality are actually the exact same thing. If you know one, you know the other. And we already did this up here, right? We did K for the constant of proportionality equals a Y value divided by an X value, and we got 1.5. And so let's check to make sure we didn't do it backwards though, because that does happen sometimes. Does it make sense that you need 1.5 cups of pineapple juice for every cup of orange juice? I think it does, right? Because you need more pineapple than orange juice. It's always a good idea before answering a question about unit rate to make sure that your rate works in the direction the question's asking for, because they might have asked me the other way. They might have asked me, how much orange juice do you need for 1 cup of pineapple juice? And if I just said, oh, well, that's the same as the constant of proportionality, so I'll just put 1.5, that would actually be the wrong answer because the question was asked the other way. So you just got to be careful with that. But in this case, it does work for us. 1.5 cups of pineapple for every 1 cup orange. Boom. Done with that. And the last one says, create a different recipe that will also taste the same as the original recipe. We can take literally any number we want. And as long as, and that could be the amount of orange juice. And then if we multiply that by 1.5 and use that as our pineapple juice amount, then the recipe should turn out the same. So we could have a giant orangey pineapple juice factory where we're pumping this stuff out by like, you know, the giant tank full because we sell it in all the stores. And so maybe we need, I don't know, what does that say? 585,452 cups of orange juice. Let me write that down before I lose it. So 585,452 cups orange. So as long as I multiply this by 1.5, I should get a correct amount of pineapple. So I'm gonna go times 1.5. So I need 878,178 cups of pineapple. So the rest of your homework assignment is on the back side of this page, the Explore section. Depending on who your math teacher is and what year you're watching this video, this may have been assigned as optional or extra credit, or it may have been assigned as mandatory. These things sort of change depending on what's going on. So I'm going to help you out with part of it. If you're supposed to do it, I'm going to let you finish it on your own. So the first part is relatively easy. It says using the digits 1 to 9 as many times as you want. So you're literally allowed to repeat them. Fill in the boxes to create 3 equivalent ratios. All right, well, since we're allowed to repeat the digits, let's just make it easy. Let's do an easy ratio like 1 to 4. Okay, well then that's the same as, ooh, wait, I should have noticed the fact that this box has, this next one has 2 boxes versus 1. So it makes sense to put the bigger number in the left, right? Because I have to fill 2 boxes here. So I'm gonna change this to a 4, and I'm gonna change this to a 1. And so now I could put like 12 here and 3 here, right? 4 times 3 is 12. 1 times 3 is 3. And then I can multiply by 3 again if I wanted to. Actually, no, I'm going to go even bigger than that. I'm going to multiply by 4. 4 times 12 is 48. 3 times 4 is 12. So all of these are equivalent ratios. But that was easy because I got to repeat the digits. This is much harder. This is much harder, actually. I don't have an answer for this saved up in my head right now or ready to go. Let's see here. Let me see if I can think about it for a second and come up with some strategy that would probably work. I'm pretty sure you want the bigger number to be in the left box. And you probably want to start with smaller numbers, if I had to guess. Like, let's see what happens if we start with 2 to 1. Okay, so that would be the same as, let's see, I'm not allowed to use 0. So what digits do I still have? Can I use 68? Oh, no, I don't want to go that big. This still needs to be single digits here. So then you can't use 2 and 1 because I need another 1 to put the teens here. So all right, so I'm going to explain my logic to you real quick and say, in case you're confused why I'm going to cross this stuff out. I still need a single digit here. But if this is a single digit and this is a 2 to 1 ratio, then this number here will wind up in the teens, right? Just logically think about that for a second. But if this number winds up in the teens, then I need a 1 to express that number, and I've already used my 1. So this is already like really hard. There's a lot of like guess and check and just sort of process of elimination that goes on here. So, okay, so what if we make it 3 to 2 instead? Okay, so I need a double digit number here, but it has to stay a single digit number here, and I can't use 1 or 2 here. No, I can't use 2 here. Okay, so what if I multiply by, see, this still isn't gonna work because if I multiply the lowest number, oh, The lowest number that will get me into the teens with my 3 is a 4. That's also the highest number I can multiply 2 by before it gets into the teens. And I need it to stay single digit number. So my only option here is to multiply by 4. But if I do that, I'm going to wind up with a 2 in this box because 3 times 4 is 12. And I've already used my 2. Oh, this problem is so annoying. In fact, you know what? I'm just going to say, no matter what year or you're ever watching this video, if you're in my class and I forget to say that this part right here is optional extra credit, and you watch this video and you hear me say that it's optional extra credit, just remind me, and I'll say, oh yeah, that's right. I remember saying that in that video 10 years ago or whatever. So yeah, if you want to see if you can figure this out through process of elimination and guess and check, go for it. Be my guest. I'm not messing with it right now. I'll see you next time.